Hey guys, so before we get started today, just a couple of housekeeping items. I'm still new to this whole YouTube thing, and so I was trying to figure out if maybe I could see where you guys are at in the videos. And I might be wrong, but it looks like I'm a bit ahead of schedule. Like I'm making these videos a few days in advance, but I think you guys are getting less time than I thought you would to watch all the videos, so I think they're all a little bit too long, and it's causing you guys to lag behind just a little bit, and that's not your fault. I'm making the videos pretty much take up the entire class space available, and it's really tight to actually fit the entire thing in the amount of time you guys have for your class. So what I was gonna do is I was gonna introduce one new concept. So my original plan, I'm gonna put this down so that you guys can maybe write it down if you want to remember it for later, but my original plan was to cover second order differential equations, second order linear differential equations, and then do a video of review, and then give you guys a test. But that's a horrible S. But what I'm thinking instead is I'll skip the second order right now. You guys are doing stuff that's at least 2 years ahead of your grade level, and at most 5 years ahead of your grade level, so I don't really care if we cover second order or not before the end of May. But what I'm gonna do is I'll do some review, I guess, of second order DEs, and then in the next video I'll make some test questions, and what I'll try to figure out is some way to get your answers back to me, but I'll make the video, I'll make a video of just the test questions that you guys can work together on as a group, because this is complicated stuff. It's not something that I'm going to make you do on your own and then have it graded. It's second year university level stuff, and you guys are all high schoolers, so you're already farther than I thought you would be at this point, and I'm really happy that you guys got to this point. But I'm not going to test you guys individually. You guys can, if you want, do it on your own, but I'm going to make it a video so that you guys can hear the question, play it back a couple times if you need to, and then work together on your answers, and then I'll figure out some way to have you guys get your answers to me. We'll have to figure out something. But yeah, so what I'll do is I'll do some review for the rest of this video and part 2 of this, and then the next video will be a test. But if you guys want, well, maybe not the next video will be a test. Whenever the time comes, I'll make the test, but at some point I'll make a little extra video on second order linear differential equations. If you guys have time, you guys can watch that. Maybe I'll film that today, we'll see. But when you guys have time, you can watch that, and we'll see if you guys understand, if you guys have time. But regardless, I won't test you on it, so I'll teach you about it in a separate video, but I won't make it something that goes on your test. So my plan was originally to do second order DEs, then the review, then the test. Now this is not really part of the current plan, so this is extra if we have time. And I mean, you guys will still have access to YouTube after the end of the school year. I'm not sure if the first thing you'll want to go and see is differential equation lessons, but I'm going to make them anyway in case you guys are interested, or in case you want to come back to them in future. But what I'm thinking is right now we'll just do some review, and then at some point there'll be a test. So whenever you guys finish these videos, you can just move straight on to the test or the little extra supplementary second order DE video at that point. So let's do some review. So, the main thing we're going to review, and the main thing that you'll be tested on, is how to solve a first order linear DE. All right, so the main thing that you're going to be tested on is this. I think I went over it a couple of extra times just to make sure, but we're going to go over it one more time today, and I'll see if I can do a new example, if I can find one, and then what we'll do is after that we'll do some new review questions, hopefully, or I'll backtrack all the way to the beginning and I'll go over anything that I might have missed, and we'll go from there. I might throw in a couple of little fun facts here and there, but first things first, let me find a good DE for us to work on. Let's see. All right, this one might be fun. Yeah, okay. Yeah, let's do this one. This is going to teach you a new integral as well. So I was avoiding this one before, but this is going to teach you a new integral. So at one point you guys might be a little bit lost, so we're going to work through this one together. All right, so we'll do an example of solving a DE instead of just the general form. All right, so we'll use the formula we talked about before and put it into practice to solve this. Y plus ty prime equals, actually yeah, sure, we'll leave that as t. I don't think it really matters. It's technically, you could have x's here, you could have anything here. The thing, and yeah, you know what, we're going to make them x's. All right, we're going to make them x's. So we're going to have x, and we're going to have x right there. So now y prime and y, everything here is a function of x. All right, in my notes, everything's a function of t. That's why I had that. It doesn't really matter. Could be x, could be t, could be z, for all I care. But so, first thing, which hopefully you've noticed, but it's very easy to miss, is that this is actually not yet in standard form. Let me remind you of standard form. That's y prime plus little q of x times y equals little g of x. Alright, so now hopefully you've noticed that the y and the y prime are in the wrong spot. It should be y prime first and then the y. Alright? So first thing we got to do is we got to put this in standard form. So we'll put the y prime term first. So we get x y prime plus y equals x squared. Alright? So that's where we start. Now, if you look at standard form, we want the y prime term here to be all by itself, right? So we don't want this x to be in front of it. So what are we going to do? We're going to divide out every term by x. So pretty much we're doing divide by x and divide by x. All right, that's pretty much what we're doing. And what it's going to give you, hand cramp. What it's going to give you is, so you have x y prime plus y all over x on this side, right, is equal to x squared over x. I hope you can see that in the corner up there. Alright, so maybe the right side will be easier to do first. X squared divided by x, that's x squared is the same thing as x times x, right? And so pretty much all you do is you cancel one x there, and you cancel 1x on the bottom. All right, and you're left with just x right here. All right, so the right side reduces to just x. That's nice. And then over here, you've got a sum. So you've got an addition problem in a division problem. And so what you can do is you can actually break it up into two fractions. Hopefully you remember this. So you have something plus something divided by x. So what you can do is you can break it into two fractions and just divide each part of the sum by x. All right? And now if you'll notice over here, now you can divide out an x and you're left with just the y prime, which is what you want. And then over here you have y over x. All right, now y over x is a little bit messy. And so what we want to actually do, just to write it in a little bit of a different way, what we want to do is we'll write it like this. So we'll write y prime plus 1 over x times y equals x. All right? So that's how we'll write it. And so the reason I've done that is because this is the same thing. This thing right here is the same thing as what we have up there. It's because if you did the multiplication, you do numerator times numerator, because this is the same thing as y over 1, right? Numerator times numerator would give you y, and the denominator is x times the 1 that we're not seeing, like that, and you'd get y over x. But we're writing it this way because now we can look at this part right here and say this is little q of x. All right? So now we have this in the form we need it to be, right? This is y prime plus q of x times y. That's this y right here, and this y prime right here is equal to little g of x, right? So based on that, we can actually state what each of those things is, right? So now we can say that little q of x is this thing in the circle, right? So little q of x is 1 over x, a little bit weird, and little g of x is just x. It's just x, right? So that's what we got there. I hope you can see that. I hope the computer glare isn't too much of a problem. But maybe this will be better? I don't know. All right, maybe I'll leave the light on for now. Hopefully you guys can read it. And so this is what we have. We have little q of x is equal to 1 over x, and little g of x is equal to just x. So now our next step is to figure out what mu is. All right? So mu, it's technically mu of x, but I'm just going to, yeah, you know what? Little mu of x, all right, is equal to e to the integral of q of x dx. All right? And what that comes out to is we need to sub in this 1 over x for the little q of x, right? So we get e to the integral of 1 over x dx. All right? Right, so, yeah, okay. Yeah, so this is going to be something a little bit new. We haven't done this yet, but it's going to kind of all cancel out in a sec, so don't worry about it too much. I can make an extra video explaining this bit as well, if you like, because we didn't really talk about this before, but the integral, if we look at just the integral of 1 over x dx evaluates to something called ln of x. So you pronounce this like L-O-N, you pronounce it like ln, and it stands for natural logarithm. All right? Now we didn't talk about logarithms before, but I'm almost at 15 minutes, but let it suffice to say for now that this integral evaluates to that. Just take that as truth, and if you come across it somewhere, I promise I won't put this on your test, but if you come across it somewhere else, just know that these two are the same. The integral of 1 over x dx is equal to ln of x. And actually, to make this slightly more complicated, it's the ln of the absolute value of x, but don't really worry about it. I'm going to come back to this at the start of the next video, and it's going to get cleaned right up. So this is a little bit of a bad place to stop, but I'll be right back in just 1 second. Sit tight.